Welcome to the Talking Ketamine podcast, the show where we explore the science behind this fascinating molecule. This is episode 39, Ketamine and Longevity.
Thanks for joining us. Today we're looking at a really cutting-edge pilot study that asks a profound question. We know depression and trauma can accelerate aging in the body, but can ketamine actually reverse that biological clock?
Okay, let's frame this analysis for you. We've looked into sources on this really remarkable pilot study. It involved 20 participants, people struggling with treatment-resistant major depressive disorder, MDD, and indoor PTSD.
Right.
They were given a series of 6 ketamine infusions. And what we're trying to figure out in this exploration is, well, can treating the mind actually make the body younger, or focusing on their biological age markers?
It really does sound revolutionary, doesn't it?
Mm.
Now, this is very preliminary work. We should stress that.
Sure.
But the researchers were hunting for molecular evidence, a signal that ketamine's benefits go way beyond just mood.
Deeper than symptoms.
Exactly. And they found, well, a really compelling signal. Quite robust, suggesting ketamine might actually be correcting biological damage right down at the epigenetic level.
Okay, let's start with the foundation here, the basic problem, because it's key to the whole study, right?
Absolutely.
For so long, we kind of separated mind and body in medicine, but the sources we looked at are clear. Chronic mental illness has, well, pretty dramatic physical effects. What's the known link between conditions like MDD, PTSD, and this idea of biological aging?
Yeah, that link is, frankly, alarming. Chronic mental illnesses aren't just in the head, so to speak. They're consistently tied to poor health outcomes, the kind we usually see in normal, non-pathological aging.
So things like heart disease, diabetes.
Exactly. If you're dealing with long-term MDD or PTSD, statistics show you likely have a reduced health span, a lower quality of life, definitely, and a higher risk for dying prematurely.
Wow.
And it's not just abstract risk. It shows up as increased rates of chronic diseases. Cardiovascular problems are a big one. Metabolic disorders, too.
So the ongoing stress, the inflammation that often comes with these conditions, it's literally making the body older faster.
Precisely. That's the idea. And scientists can actually measure this. There's foundational research out there showing a clear connection between severe chronic MDD and PTSD and something called DNAM-age acceleration.
DNAM-age acceleration.
Yeah, put simply, the biological toll of the illness seems to speed up your internal clock. Your cells effectively look biologically older than your birth certificate says they should be.
Okay, so if depression and trauma are speeding up this clock, the obvious next question is, how do scientists measure it? How can they look at, say, a blood sample and figure out someone who's 40 chronologically is actually maybe 50 biologically?
Right, that measurement, that's the crucial part. It's done using what are called epigenetic clocks.
Epigenetic clocks.
The technology zeroes in on DNA, methylation DNAM for short. These are like tiny chemical tags on our DNA that control which genes are active and which aren't. And these tags, they change in really predictable patterns as we live our lives. So their patterns become reliable biomarkers, indicators of our true biological age.
Could you give us an analogy, maybe help us visualize the difference between chronological age and this biological age?
Sure. Think of it like a car. Your chronological age is the year the car was manufactured, say, 2015. Easy enough.
I thought.
But your biological age, that's the actual condition of that 2015 car. It reflects the mileage, how well it's been maintained. Has it had regular oil changes? Is there rust building up? So a poorly maintained 2015 car that's been driven hard for 300,000 miles is biologically much older than, say, a classic 1995 car that someone pampered, kept in a garage, barely drove.
Right. Makes sense. The year doesn't tell the whole story.
Exactly. Epigenetic clocks measure that cellular rust and mileage. They assess the wear and tear separate from just your date of birth.
And the tools for measuring the cellular wear, they've gotten quite a bit better recently, moved beyond just predicting how old someone is.
Oh, absolutely. The first generation of these clocks, they were mostly designed just to guess your chronological age, which is interesting, but maybe limited.
Right.
The current second-generation clocks are much more powerful. They measure clinical features, things that are strongly linked to aging-related diseases and mortality risk. More predictive.
And the study we're looking at used these newer clocks.
Yes, it focused specifically on these predictive second-gen clocks. The main ones were PhenoAge, that's F-E-E, no-age, GrimAge V2, GrimAge V2, and a really integrated one called OMICs-AGE, OF-my-fam-age.
OMICs-AGE, that sounds like the most advanced one. What's special about that particular clock? Why is it so powerful for a study like this?
Well, OMICs-AGE is what scientists call an integrative approach. It doesn't just look at those DNA tags, the methylation patterns.
Okay.
It actually combines that epigenetic data with surrogates, basically, stand-ins derived from methylation for 16 proteins, 14 metabolites, and 10 clinical markers.
Wow, that's a lot of data points.
It is. It pulls all this information together from 8 different physiological systems. So because it captures such a wide systemic view of health, OMICs-AGE has shown some of the strongest, most consistent links to future mortality risk.
And importantly for this study,
And importantly, yes, also strong links to depression risk. It seems really well suited to capture the kind of total systemic breakdown or maybe recovery associated with illness.
okay, so let's get to the findings. We have these 20 participants. Their biological clocks apparently sped up by chronic MDD or PTSD. They get 6 ketamine infusions, standard sub-anesthetic dose, over 2 or 3 weeks.
Right, 0.5 milligauge infusions.
Blood samples taken before, and then again 10 days after the last infusion. Now, we'd expect them to feel better clinically, right? Less depressed, less traumatized.
Definitely.
But what did those biological clocks show? Did the clock just slow down its ticking, or did something more dramatic happen? Did it actually reverse?
It reversed. That's the headline finding. I mean, first, the clinical results were definitely outstanding, just as expected. Symptom scores dropped significantly.
How significantly?
We're talking a median improvement of 33 points on the PCL5 for PTSD. That's huge. And an 11-point median drop on the PHQ-9 for depression. Really substantial relief for these individuals.
Okay, that's great news in itself. But the aging markers?
That's where it gets potentially groundbreaking. The study found a clear, statistically significant reduction in epigenetic age across several of those second-generation markers.
A reduction. So younger biological age after treatment. Which clocks showed this?
They observed it in PHENO-AGE and also in Grimmage V2. But the most robust finding, the strongest signal by far, was detected by OMICs-AGE.
OMICs-AGE again.
Yes. That specific clock showed the largest degree of age deceleration or reversal across the whole group.
That is a strong signal. But, as you said, it's a pilot study, small numbers. Sometimes these exciting initial findings don't quite hold up later in bigger trials.
That's always the concern, absolutely.
So what makes this OMEC signal seem particularly trustworthy here?
Well, that's where the scientific rigor really comes into play. The researchers didn't just report the initial finding. They did further analysis, performing really strict statistical adjustments.
What kind of adjustments?
Controlling for things like potential batch effects in the lab work, other technical variations, things that could potentially skew the results. And crucially, after all these adjustments, OMICs-AGE was the only biomarker whose reduction in age remained statistically significant.
Ah, okay, so it held up under scrutiny.
It did. It passed what's called the Bonferroni correction for multiple comparisons. That tells us the anti-aging signal captured by OMICs-AGE is less likely to be just a fluke, a random fluctuation. It suggests a genuine, coordinated biological response to the ketamine.
So let's just state it clearly for you listening. A series of 6 ketamine infusions seem to actually roll back the biological age clock in these patients with severe mental illness.
That's what the data suggests, yes.
The implications feel enormous. It points towards ketamine affecting these deep mechanisms of aging itself, maybe reversing some of that biological damage we know is caused by chronic depression and trauma.
It certainly opens up that possibility.
Which brings us to the huge question, the how question. If we accept this age reversal signal is real, what does the science currently suggest about how ketamine is pulling this off physically?
Right.
Is it directly fixing the DNA methylation tags, or is it more indirect? If you feel less stressed, sleep better, maybe your body just naturally starts to heal and reverse that aging process on its own.
It's probably a bit of both, a multi-layered process. There's likely some direct molecular action from the ketamine, but also significant secondary benefits from reducing the overall burden of the illness.
Okay.
But the evidence from this study points quite strongly towards specific immune and metabolic pathways being involved.
Immune and metabolic. Tell me more.
Okay, so specifically, the study found a significant reduction in a particular type of immune cell after the ketamine treatment, CD4T memory T cells.
CD4T memory T cells. What's the significance of those going down?
Well, these CD4T memory cells are generally associated with increasing systemic inflammation. Their numbers typically increase as we get older.
Ah, okay. Part of the aging process itself.
Exactly. They're positively linked with biological age acceleration. So when the immune system shows a reduction in these specific cells after treatment, it signals what you might call a younger or at least a healthier inflammatory profile. less chronic background inflammation.
Interesting. So it's evidence that ketamine might be tamping down on what scientists sometimes call immunosenescence, that kind of age-related immune decline and inflammation.
That's a plausible interpretation,
Yeah.
yes. It fits with ketamine's known anti-inflammatory properties. We're seeing a potential link between those properties and this actual biological age deceleration.
Okay, so the immune system is one piece. What other internal pathways did these epigenetic clocks point toward?
So the analysis also looked deeper, using something called epigenetic biomarker proxies, or EBPs.
Okay.
These are basically those methylation surrogates we mentioned earlier, standing in for various metabolites and proteins in the blood.
Right.
And ketamine treatment led to significant shifts in several of these EBP markers. And crucially, these markers are associated with major metabolic and neuroimmune pathways.
Can you give some examples?
Sure. They saw changes in the methylation surrogates for things like adenosine, BUN, that's blood urea nitrogen, related to kidney function and protein metabolism, various carnitines, which are involved in energy production, and proline, an amino acid linked to stress response.
And these are all relevant to depression or ketamine.
Yes, all of them have previously been linked in research to depression, to general metabolism, or even directly to how ketamine might work in the body.
So we're not just seeing random changes, we're seing coordinated shifts in key biological systems. Immune function adjusting, inflammation potentially dropping, core metabolic processes shifting.
Exactly. It looks like a convergence, all pointing towards a younger biological profile emerging after the treatment.
And was there an even more detailed view, like which specific genes or processes were most affected?
Yes, they did an epigenome-wide association study, an EWAS. This looks across hundreds of thousands of methylation sites on the genome.
Okay.
And it found that the specific DNA sites showing the most significant methylation changes after ketamine were enriched, meaning they were clustered in biological processes related to two key areas: circadian sleep regulation and the regulation of T-cell differentiation.
Circadian sleep and T cells, that connects back directly to what we already know about ketamine, doesn't it?
It really does. It links ketamine's known positive effects on sleep cycles, its chronotherapeutic effects, and its anti-inflammatory effects, which involve T cells, directly to these measurable systemic epigenetic changes.
So the biological clock correction isn't some mysterious side effect. It seems tied right into the known therapeutic pathways of the drug.
That's what this evidence strongly suggests. The age reversal seems coupled to these core neuroimmune and metabolic adjustments.
So let's try to wrap this up. This analysis seems to confirm two really powerful ideas for you, the listener. First, maybe stating the obvious, but chronic mental illness causes real, measurable biological aging and damage. It's not just in your head.
Absolutely clear.
Second, and this is the really exciting part, a rapid-acting treatment like ketamine appears capable of triggering these coordinated neuroimmune metabolic shifts, changes that can potentially reverse some of that biological damage.
It's a phenomenal signal, truly. But, we absolutely have to apply the scientific brakes here. Be cautious.
Yeah, the caveats.
Yes. This is a small pilot study, remember, only 20 people.
Right.
And critically, for the biomarker part, it didn't have a non-treatment control group to compare the aging changes against directly.
Important limitations.
Very important. So we can't definitively state, based only on this study, that ketamine caused this age reversal in a way that rules out all other possibilities. We absolutely need larger randomized controlled trials to confirm this.
Future research is essential.
Essential. However, the fact that the OMIC-AGE signal in particular was so strong and that it held up even after those really tough statistical adjustments, that strongly suggests we're looking at something profound here. Something about ketamine's potential to actually function as an age decelerator in the context of mental illness.
It really reframes how we should think about public health,
Yeah.
potentially. If conditions like MDD and PTSD are so tightly woven into these inflammatory and aging pathways, then maybe the ultimate longevity treatment for potentially millions isn't going to be found in some fancy anti-aging cream or supplement from Silicon Valley, but simply in effectively, rapidly, and aggressively, treating the mental distress that's speeding up the biological clock in the first place. Mental health really is longevity health.
That's a truly important realization, I think. A powerful takeaway.
Absolutely. Thank you for joining us for this analysis of the science.